will take 4 ones also. If I just do a bitwise.
Okay, so hope I'm audible enough. See, actually, what happened is you have to understand the link, the management, the college management will give you a link. Actually, the slight problem because the previous responses were not deleted, and that is the reason. That is the reason it was not giving you, so you couldn't able to answer it. Okay, so I'm reposting the link again. Hope I'm audible to everyone. I'm reposting the link again, and I'm also switching on the responses. Okay, so please everyone, in the meantime, you can again repost it. We have deleted all the previous responses. Okay, so now you can okay, so now you can delete it. Okay, I mean you can give your responses. So I'll give you okay, so my sound is low. Okay, I'll give you just a moment. Okay, so I'll give you as I said 3 minutes time. Okay, or I will give you 5 minutes time. In the meantime, everyone, please give your attendance. Okay, so I have reposted your attendance and I'm accepting responses. So everyone just redo it again. Okay, so go on. I have given you enough time. Okay, please go on. Give your attendance. Okay, thank you for responding. Thank you by saying that the audio is it is audible. Okay, so please go on. Whoever gave your attendance again, please give your attendance again. Okay, so please read your attendance as I've given there. Okay, so please go and give your attendance back. So the timer will be on. Okay, everyone, please give your attendance. Okay. So now in the meantime, as we are doing it, okay. So whatever doubts you have, you can just post it here, and I'm ready to clarify it. Okay. So whatever doubts you have, please post your doubts here, and I'm ready to clarify it. Okay. So based on today's content, as you must have seen, okay. So please post your questions based on today's content, and I'll be asking questions based on that. Okay. So please, everyone, post your queries. Okay. So everyone post your queries, and I'll be explaining it. So please everyone post your queries. Okay, and I'll be ready to answer it. Okay, so let's wait for 1 more minute. Okay, let them complete the attendance. So let us wait for 1 more minute. Okay, in the meantime, please post your queries. Okay, so in the meantime, please post your queries and I'm here to answer it. So last 1 minute 30 seconds, just let them complete it. Okay, just 1 more minute. So people are getting 1 minute. Okay, let all of them give their attendance because many of them have given it and they are saying that they did not get the message. So I'm just talking with them. So just let's wait for 1 more minute. Okay. So don't worry about it. I will teach the power of two again. Okay. Now listen here. So I think everyone have given their attendance. Okay, so let's close it for the moment. Okay. Now focus. Okay. Now focus, everyone. Okay. See, I'll be just telling you how to find the power of 2. Any given number is power of 2. Okay. Just a moment, just 1 minute. Okay, just 1 minute. I'm just closing the responses. So I hope everybody of you gave your attendance. If there's any problem or issues, so you can just contact us. No issues in it. Okay. So I think I hope everybody have 1 minute. Your faculty is calling me. Just a moment. Okay, okay. So I think the attendance problem is solved. I'm sorry for going again. Okay. So the small problem in the link. Okay. Okay. Let's come back. Let's go to it. Okay. Now what I have to do is I have to find whether the given number is a power of 2. That is what I have to do. Okay, so let us go as usual. Okay, first let me explain the algorithm clearly. Okay, okay, let me explain the algorithm clearly. How can we find whether the given number is power of 2? Let's say a number. Okay, let's have a number. Okay, and let's imagine this number. So whatever number we have. Okay, so let's say that is the number we have to find whether it is power of 2 or not. Okay, the next thing what I have to do is, okay, now carefully listen. So, as you have seen, okay, let me open an Excel sheet. Just a moment. Let me open an Excel sheet to explain you how it works. Just focus. Okay. Now imagine I'm going to have 8 bits here. Imagine I'm going to have 8 bits. Just focus. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's say. And then this is 2 power 0. Okay. 2 power 1. 2 power 2, and then 2 power 3, it goes on. Okay, and then 16, 32, okay, 64 and 128. Okay, so these are the bits. So how can I find whether it is in 2's power or not? As you all know, this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6 and 2 power 7. Okay, now it is very easy for us to find, okay, so whether it is in 2's power or not. How? Okay. Now, when you take a number, let's say the given number is 32. If the given number is 32, okay. So if the given number is 32, this particular bit will be on, whereas the other bits will be switched off. This bit will be on, whereas the other bits will be switched off. Okay. And now what are we doing? Okay, so in this problem, what we are doing is we are using the right shift operation. We are using the right bit switching operation to find whether it is 2's power or not. Whether it is 2's power or not. Okay, let me give you a small example. Okay, let me give you a small example. Imagine if I right shift this. Imagine if I right shift this, what will happen? Okay, imagine if I right shift this for 1, what will happen? This one, this particular one, what you see here, will move to the next one. If I right shift, If I right shift this particular one will move to the next bit, which becomes 2 power n minus 1. Again, if I right shift this, it goes to the next bit, which becomes again 2 power n minus 2, which is 8. Again, if I right shift this one will go to the next one. Again, if I right shift this one will go to the next one. Okay, and if this one moves to the next one, what happens? From 32, it is coming to 2. Okay, and this again, if I right shift, this will come here. Now, from 32, it became 1. How many times I shifted? 1, 2, 3, 4, 5 times I shifted towards the right. Okay. In case, imagine your value is 2 power 0. Your value is 2 power 0. What do you mean by 2 power 0? 1. If I left shift this, if I left shift this, what will happen? Just closely look into it. If I left shift this, what will happen? If I left shift this, for example, imagine this is the given number. So if I say number, okay, left shift for 2, if I say number left shift for 2, what will happen? Imagine 2 times I'm shifting to the left hand side, so this one will move to the next one. Again, this one will move to the next one. Okay, so we are using these operations to find whether they fall under the 2's power or not. Okay, now let's go to the program. Okay, how can we use it effectively? Now just please, okay, 1 minute, just a moment. Okay, focus. Everyone, please focus. Okay, and now I'm going to the program. Okay, so let me start from the scratch. Okay, focus. Let me start from the scratch. Hash. Okay, let me save it. Okay, and demo. Okay, hash include and then standard import.h. Okay, and then main function. Okay, now we got it. Create a variable called number and get the number from the user. So scanf format specify d. Okay, and just a moment, and store it in the location of number. Okay, we have done it. Okay, what is the next step? Now the number may be anything. Okay, the number may be anything. Now what we have to do is, using the bits concept, okay, we have to find in which 2's power it falls under. Okay, so for that, what we have to do is, we have to check whether at least one of the bit is switched on. At least one of the bit is switched on. So for that, what we should do, just think about it carefully. How can I find at least one of the bit is switched on? Okay, so now as I showed you the Excel sheet here, okay, here when one of the bit is switched on, it means that it is already in 2's power. It is already in 2's power. That is what we are going to do, and that is what we are going to follow. Now carefully listen. Okay, focus. Just come to the program. Okay, we have the number. Now we have the number. Now how can I use the bitwise operator? Okay, now focus carefully. Now let me repeat the process again. If you have 1, okay, let me explain clearly. If you have 1, which bit will be on? It will look like this. If I have 2, it will look like this, 1 0. Okay, 4, for 4 how it will look? For 4 it will look like 1 double 0, and 5 1, okay, sorry, 8 1 triple 0. Let me minimize it. Okay, so I'm giving a pretty clear idea what will happen if 16, okay, 1, no extra 1 0. Okay, and let me go to the next number, that is 32. As you can see here, you will have 1 0 0 0, as you can see in hierarchical structure here. Okay, so 64 and 1 0 0 0. Okay, so this is pretty much the image, and these are the decimal values for your 2's power. And this is what we are going to check in the bits, whether they fall under any of this category. So now carefully listen how we are going to accomplish it. Okay. First, get the number from the user. We have got it. What is the next step? Okay. Whether it is in 2's power or not. How can I find whether it is 2's power or not? Okay, very simple. If, if, okay, just focus. If the number, if the number and the bitwise operator, if the number and let's say number minus 1. Okay, now focus please. Okay, number and number minus 1. Okay, this is a formula which you have already learned. Okay, number and number minus 1 not equal to 0. Okay, let's see what happens if number and number minus 1, okay, if I give not equal to 0. Okay, so not equal to 0. If this condition is satisfied, if this condition is satisfied, okay, if the number and number minus 1, if they are not equal to 0, or if they are equal to 0, what I can say is that I can return, I can return it is true. Okay, or return 1, else, okay, return 0. Let us see what happens if I give this statement, and then I'll explain what this statement is clearly about. Okay, just okay. Now let me run this and show you what happens exactly. Just a moment. Okay, now so what I've given you is whether this is true or false. So in the area of true or false, what I'm going to have, just say printf yes, okay, or give a no. Okay, now let's see what happens. Okay, let me give, let's say 64. Okay, it says yes. Okay, now let me give 32. It says yes. Now let me give 65. It says no. Now let me give 128. It says yes. Now let me give uh, 39. It says no. So what exactly happens in this statement? What exactly happens in the statement? Now what is number? 32. What is number? 32. What is the binary equivalent of number? Just now I showed you in the chart. Copy this exactly. What is the binary equivalent of 32? This. Okay. And what is number minus 1? What is number minus 1? What is number minus 1? That is what we're going to see. So number and number minus 1, both the numbers. Okay, what is number minus 1? 31. 31. And what is the binary equivalent of 31? Now focus here. What is the binary equivalent of 31? The binary equivalent of 31 is 1. Add 16, add 1 as well here. Okay, let's see what is the binary equivalent of 31. Okay, add 16, yes, and then add 8, now 24. Okay, and then add 4, 28. Okay, add this, it becomes 31. Okay, 30, and then add this and this gives you 31. So all these numbers together gives you 31, and this number alone gives you 32. Okay, so now go back, so what I'm doing is 0 1 1 1 1 1, and now I'm trying to use the AND operator as the truth table, and if I use it, what will be my answer? 1 and 0 is 0, 0 1 is 0, 1 0 1 is 0, 0 1 is 0, 0 1 is 0, 0 1 is 0. So everything is 0. If they together go, this is power of 2. Now for example, likewise for 64. What is the binary equivalent of 64? The binary equivalent of 64 is this. The binary equivalent of 64 is this. So in case if the searching number, if the number you are searching for falls under any of the two's power, definitely if you subtract the number minus 1, the following elements should be 1 only. You take 64. What is 64 minus 1? 64 is this, and what is 64 minus 1? 64 minus 1 is this. This is 64 minus 1. Got it? So you take 128. What is 128? Let's say what is 128. Okay. This is 128. Okay. Now if I want to have 127, what is 127? This is 127. So any two's power you take, if you subtract it by 1, definitely all the upcoming bits will be 1 only. All the upcoming bits will be 1 only. Okay, let me take some other number. Sir, this is somewhat coincidentally working. Okay, let me take some other number. Okay, okay. Let me take, let's say, let us go with this number. That is 5. What is 5? 5 is, or okay, 15. What is 15? Okay, this is 15. Okay, 8 plus 4 plus 2 plus 1. Okay, so what is 15? Is 15 a 2's power? Not at all. What is 15 minus 1? 14. How can I have 14? How can I have 14? To have 14, this is 14. So you are literally using the truth table 1 1 1 1 1 4 ones, and you are just comparing it with 1 1 1 0. Do you think both of them, if I use truth table of AND operator, if I do a bitwise AND, will I get 0 here? I will not get 0 at all. What will be my answer? 1 1 1 0 will be my answer. So this is not a two's power. So this is the logic to find whether it is a two's power or not. Simple. Got it, everyone? Okay. If you have any questions regarding this, please post your queries.